Theoretical recap. At OSI Layer 1, physical, the cable is not just a wire, it is a medium that determines speed, distance, interference, resistance, and ultimately, the reliability of your entire network stack. Three main cable families dominate enterprise and lab environments: twisted pair copper, Cat5e, Cat6, Cat6a, coaxial, and fiber optic, single mode versus multi-mode. Each has specific use cases tied to bandwidth requirements, distance constraints, and environmental conditions. A common beginner mistake is to treat all Ethernet cables as interchangeable. They are not. Cat5e supports up to 1 gigabit per second over 100 meters, while Cat6a reaches 10 gigabits per second over the same distance. Fiber optic eliminates electromagnetic interference entirely and can span kilometers, critical for inter-building links or data centers. Coaxial cable, while older, still appears in specific contexts such as cable internet or legacy CCTV systems. Another frequent error is ignoring the connector type and the directionality of the link. A straight-through cable connects different device types, PC to switch, while a crossover cable connects similar device types, switch to switch, though modern devices with Auto MDI/MDX largely handle this automatically. Understanding these distinctions is foundational for troubleshooting physical connectivity issues, a skill directly relevant to network reconnaissance in cybersecurity contexts. Mental model. Think of the cable as the highway. The category or type defines the speed limit and maximum length. Choosing the wrong highway means your data never arrives, or arrives corrupted. Workshop brief. Welcome to this practical workshop on physical media selection. You have just completed the Layer 1 physics lesson and have built a solid understanding of OSI model fundamentals and network topology. This workshop bridges theory and real-world decision-making. You will be placed in the role of a junior network technician who must make cabling decisions across a set of distinct infrastructure scenarios. Your ability to justify each choice analytically is as important as the choice itself. Scenario overview. You are given the following 5 infrastructure scenarios. For each one, you must select the most appropriate cable type and justify your answer in writing. Your justification must reference technical constraints, distance, speed, interference, environment, and connect your reasoning back to OSI Layer 1 principles. Scenario 1. Office floor deployment. You need to connect 24 workstations to a central access switch in an open-plan office. The longest run is 45 meters. Budget is limited. Speeds of 1 gigabit per second per workstation are required. Scenario 2. Inter-building link. 2 buildings on the same campus are 350 meters apart. The link must carry 10 gigabits per second of throughput and cross a parking lot with heavy electrical equipment, generators, vehicles. Downtime is not acceptable. Scenario 3. Data center spine leaf connection. You need to connect 2 top-of-rack switches within the same data center rack row. The distance is under 10 meters. Speed requirement is 100 gigabits per second. Scenario 4. Legacy CCTV integration. An existing surveillance system uses coaxial RG59 cabling throughout a warehouse. You must extend the network to a new IP camera while reusing the existing cable infrastructure and a coaxial to Ethernet adapter. Scenario 5. Home lab, pen test lab setup. You are building a personal pen test lab with 3 machines connected to a small unmanaged switch. Distance is under 2 meters. You want the cheapest reliable option with at least 1 gigabit per second. What you must produce. For each of the 5 scenarios, write a structured response that includes 1. Your cable selection with the specific category or type. 2. A technical justification of at least 3 sentences explaining why this cable fits the constraints, and 3. At least 1 alternative you considered and why you rejected it. Your full submission should be between 600 and 1,000 words. You may present your answers as a numbered list, 1 section per scenario. In addition, write a short conclusion paragraph, 100 to 150 words, reflecting on how physical media choice at Layer 1 can have upstream consequences on security, performance, and network topology design. Connect this to what you have learned about OSI encapsulation and the role of the physical layer in supporting all layers above it. Advice and guidance. Do not guess, reason from constraints. Every scenario contains enough technical details to eliminate at least 2 or 3 cable types immediately. Start by listing the hard constraints, distance, speed, environment, before considering cost or preference. If you are unsure about a specific cable specification, consult your previous Layer 1 course materials or look up the official IEEE standards online. The 802.3 family covers Ethernet physical media in detail. Wikipedia's articles on structured cabling and fiber optic categories are reliable starting points. Watch out for the interference trap in Scenario 2. Many beginners default to copper because it is cheaper, but electrical interference from external equipment is a disqualifying factor for copper over long distances. Similarly, in Scenario 3, do not confuse multimode and single-mode fiber. Short distance, high-speed intra-data center links have specific optics requirements. You are allowed and encouraged to consult all previous course materials, including the OSI model lesson, the encapsulation activity, and the Layer 1 physics chapter. Use any reliable internet resources. You may discuss scenarios with peers or ask for help, but the written justifications must be your own analytical work. Submit your completed document before the deadline. Late submissions will not be accepted.